Hey guys, and welcome back to Lesson 4 in the Real Numbers course. In this lesson, we're going to continue our discussion and in fact wrap up our discussion of the integers. So let's get right to work. This course is all about the real numbers, and we started right at the very beginning talking about the whole numbers. And that led us, in our last lesson, to introduce the integers. So the integers, remember, are all the whole numbers together with their opposites. They form this really cool universe of the positives, 0 in the middle, and then the negatives. Now, we also saw in our last lesson that the positives and the negatives, they don't get along. They hate each other. They're always going to be fighting. And in fact, if you take a number and its opposite, you know what you get. Remember that? You get, we got lots of complaints after our last lesson with the scary sound effects.
Total annihilation.
In other words, you get 0 left when you add a number and its opposite. So for example, if you want to add negative 318 to its opposite, 318, you get total annihilation. In other words, you get 0. Now, if you take a positive and a negative and add them, but they're not quite opposites, then you don't get total annihilation. You get some annihilating. But to figure out what you're going to be left with, we came up with a really cool representation of this in our last lesson. Remember that? The n's and p's? So for example, with this one, negative 8, we represented with 8 n's, n for negative, obviously, and 4 p's for the positives, right? The 4 positives. Now, we let the annihilating happen. Remember, a negative and a positive, those opposites, they annihilate each other. So I'm just going to annihilate them right there. And then we see what we have left. Well, I see these 4 n's left, meaning we've got 4 negatives left, and that's our answer. All right, there's still a fight, there's still some annihilation, but it's not total because those weren't opposites. At the end of our last lesson, we considered this problem. All right, so now it's getting up there. This is a big fight. We had negative 53 plus 50, and we said that writing the n's and p's, maybe that's not the way to go on this one. That would be a lot of n's and p's. But instead, maybe we can think about this in the same way, but without the writing. So let's ask ourselves the following questions. Number 1, in this fight, which group has more guys? The negatives or the positives? Well, check out the two numbers. Okay, it looks like if you had all the n's and p's up there, it looks like you'd have more n's than you do p's, right? So the negatives have more guys in them, in that group. So right away, you know what? When the fight happens and the dust settles, we know who's going to be left standing. There are going to be negatives left. So I'm going to put that negative in because I know my answer is going to be negative, just to record that so I remember it. Well, how many negatives are going to be left after the annihilation? Well, take a look at the numbers. You might even be able to see it, right? Just take a look. It looks like we have 3 more negatives than we do positives. So when all the annihilating's done, we're going to have negative 3, or 3 negatives left. Negative 3. That's all there is to it. Okay, so we're sort of using the n's and p model, but without writing all the n's and p's. Okay, so for example, if you want to try this problem, negative 108 plus 120. Well, let's ask ourselves the same questions. When this fight happens, and there's going to be a fight, which group has more guys in it? This time, good eye. It's the positives that have more guys in them. So the answer is going to be positive. Now, I'm not really going to put a plus sign there. We don't usually do that with the positives, but I'll just remember, okay, it's going to be the positives that are left standing. Maybe I'll just write myself a note My memory's not what it used to be. Okay, the positives are going to win this fight. Well, how many positives are going to be left? Well, let me see if I just look at those two numbers. I got 108 negatives. I got 120 positives. It looks like the positives have like 12 more guys, right? There'd be 12 more P's than N's if I wrote, God forbid, all those N's and P's out, right? Looks like 12 to me. So when the dust settles, there's going to be positive 12 left over. Got it? Looking good? All right. That was really the main point of our discussion here today. You can use the N's and P's model if you want to see them, and it works well for small numbers. But for big numbers, nobody's going to write all those N's and P's. Just try to reason it out, just like we did here with those two questions. All right? Before I let you go today, I want to show you one thing, and this is a cool way to end our fourth lesson here. There's something in mathematics called the 3n plus 1 phenomenon. And I want to show it to you because it's cool for all kinds of reasons, but one of the coolest is it's an open question in mathematics why this phenomenon works the way it does. Open means nobody really understands exactly why it works. So let me show you the rules here. What you do is you choose a whole number. Pick a whole number, any whole number. If the number you picked is even, you immediately divide it by 2. But if it's odd, you don't do that. You instead multiply by 3. Whatever you get, you add 1 to it. All right? So two different moves depending on what kind of number you pick. Well, whatever you get after doing those moves, you take the new number and you just repeat it. So you ask yourself, okay, is it even? Then you do your thing. Is it odd? You do your other thing. And you just repeat it. So let me give you an example, okay? Let's say we start with 6. All right? I just picked a whole number at random. So I look at my rules. If it's even, you divide by 2. Well, all right, 6 is even. So I'm going to divide it by 2. That means I get 3. Right? 6 divided by 2 is 3. Now, repeat the process with 3. Is it even? No. Is it odd? Yes. All right, so what do? We multiply by 3, and then we add 1. So 3 times 3 is 9, plus 1 is 10. Good. Our next number in this sequence is 10. All right, go back to the rules. It's even, so we divide it by 2, right? So 10 divided by 2 is, yell it out, nice, 5. All right, good. Let's repeat the process. 5 is odd, correct? Yep, so we're going to multiply by 3 and add 1. So do that in your brains real quick and shout out. Good, 16. 5 times 3 is 15, plus 1 more is 16. Very nice. Very nice. All right. Even divided by 2. 16 divided by 2 is 8. 8's even. So again, divide it by 2. 8 divided by 2 is 4. Oh man, it's a string of evens. 4. So we got to divide it by 2. That's 2. And yet another even. 2 is even. Divided by 2, you get 1. I want you to notice something. Once we get to 1, if we multiply by 3, add 1, 4, it's going to put us back right here, isn't it? And then we're going to divide it by 2. Get that. Divide by 2, we get 1. So that is important. That's the phenomenon. Every whole number that you start with, it eventually has gone down to 1. Every single time. No matter what number we've started with. All right? And it's an open question. Nobody understands why this works or if it always works. So I'll tell you what. If you guys want to try a bunch of numbers and just try the process, following the rules, and if you can find a number that doesn't eventually go down to 1, whoa, okay, that would really be something. I'll tell you what, it would be big news. So if you find one, if you find a number that doesn't go down to 1 when you're doing this, don't tell anybody else. Tell me. Just send me an email message, and then I'll announce it to the world. And I'm going to be so rich and so famous. It's going to be so sweet for us. Okay? I mean, I'll take the money and the fame, but you'll have the satisfaction of finding that number and then telling me. Cool? All right. Tell you what, if you want to try one of these just to get an exciting one, start with 23. See what happens. Okay, I'll tell you what. Ooh, wouldn't this be cool if instead of starting with a whole number, you started with an integer? I wonder what happens with that. Sounds like a star problem kind of question to me. Anyway, guys, excellent work on this quick lesson. When we come back in our next lesson, lesson number 5, we'll continue our exploration of the real numbers. We've got our integers in place. The next place we need to look is in between them. It seems like there's lots of space in between those integers. Well, that brings up the question. Well, are there numbers in between? And if so, how many? That'll be the subject of our next lesson. Take care, guys. Great work. See you later.